This meeting is being recorded.
So, hi everyone. It's me and Nelson again. This Friday we are looking at chapters 15 and 16. Eloquent Ruby is still the book. And today for a change, we have no video for you guys, so you'll just have to listen to the audio. So all this time we've been looking at classes. We've looked at testing and several other things. Chapters 15 and 16 are related in a way that both of them deal with modules. And we are going to look at how modules differ from classes, what is the importance of modules and where do they apply, how to mix in a module into a class and provide the modules method for either the class or the instances of the class which we are mixing the module into, and how modules, just like everything else in Ruby, are objects. So chapter 15, the page is 181. Nelson, are you there?
Yeah, I'm here.
Yeah, the page is 181, sorry. So the author introduces by telling us that as a program grows in complexity, we are going to have to come up with ways of organizing the code such that we can understand what each facet of the application is doing at any one time. And it provides modules as one of the ways of organizing various pieces of behavior into a whole. And of course, just like the classes we looked at before, modules kind of serve a purpose similar to what we saw that classes do, in that we have classes being this collection of behavior, which is something that modules do as well. So moving on to page 182, we create our very first module, which is a module called rendering. And basically what this module is associated with is rendering the font as well as rendering the paper size. And here we see a way of accessing the font class and a way of accessing the paper size class, which is inside the module rendering. And what we see here is kind of like a syntax rule whereby you have the name of the module, and then you have the double colon, and then the name followed by the name of the thing you want to access. In this case, we have rendering, a double colon, and then the font. In this case, font being the class that is nested or that is enclosed within the module rendering. And the same logic applies if we wanted to access the paper size class that is still nested in this module. We say rendering, the double colon, and then paper size. And then we have to ask ourselves, why would we want to access both these classes that are enclosed by the rendering module? And an answer to that is simply because, let's say we want to create a new instance of the font class or a new instance of the paper size class. We could just say rendering double colon font, and then we call the new method, and then we pass in the argument. And that will give us a new instance of the font class. Moving to page 183, like I said before, modules are just containers for things, and they differ from classes in the way that for modules don't allow you to create instances of a module, just like a class allows you to create instances of a class. What modules do is that they act as a container for behaviors, and this behavior could be anything from methods to what we've seen before, which is classes, whereby the classes are nested within the module, And then another thing that we see here on page 153 is constants into being stored within a module. And I think that is pretty much self-explanatory. We saw that classes can be within a module, constants can be within a module, and now methods themselves can be enclosed within a module. And that is where we move to chapter 184.
Yeah,
We see a module.
let me just say a little something about what we've covered. So the uh, in the on page 182, where we have the example where the rendering module is wrapping the font class and the paper size class.
Yeah,
Later on he discusses that you can put these into individual files, and that I think that that's the preferred way of using modules is that the font class would go in a separate file. It would get wrapped in a rendering module. The paper size class would go in its own file, and it would get wrapped in a rendering module, and that module is additive, so so it has the same effect of of the example that we see on page 182. The only difference is that when you're searching, like that file needs a name, right? And when you're
yeah,
searching for, like, let's say the font class, you want to be able to search for font and find it. And you don't want to you don't want to get yourself in a situation where you're searching for paper size. So what you have to do is search for the font class because the font file, like font.rb, is going to have the paper size class in it. Like that's not a fun way to work. Um, so it's probably preferable to put these into their own files and wrap them into modules. And when like part of this module thing is like we're saying yes, they're acting as containers. But that container is also a namespace, which is which is like you're giving a name to everything, to all the classes underneath this, and that helps you separate out ideas. And so these modules are a way of organizing your code, but we're organizing our code for the purpose of helping us separate out different ideas into different places.
yeah.
Yeah. Okay.
So there's a question I have about that section that he talks about, whereby you get this code that defines a class font and you put it in its own file. So I'm kind of having trouble understanding this. When you say we put the code that is related to a class, now let's say font, we put it in a file named font.rb, and then we do the same for the paper size class. So where are the required statements going to go? Are they going to be defined inside the rendering module, or I don't know if you got my question.
Um, well, let's look at page 185 because, and I know this is further on down the line. It's past the point of where you've already covered.
Yeah,
But
yeah,
it separates out. The first example says module rendering, and then inside that rendering, it has a font, and then the second example has a module rendering, and inside of that, there's a class paper size. So when and when you want to use the font class, you you can do one of two things. You can either say explicitly, write out the words rendering double colon and then font dot
Yeah,
new to use that class,
yeah,
or you can include like in the cases of where you don't want such a long name, you can just say include rendering, and then you can just reference the class font directly without prefixing. So if you're creating many fonts, or if you're addressing fonts and the other paper size class, which is also in the module rendering, you don't need to use the explicitly use the namespace every single time. You don't want to have to write it out every single time. You can just include the module and then just write out font.new and paper size.new.
oh, okay, okay, it makes sense now. I don't know about this part though, because as so far what I'm understanding from what you've told me is that the purpose of of using include to mix a module into a class is to do away with that syntax whereby you write the name of the module and then the double colon. I think that's what you're driving at, right?
Yeah, yeah.
But
I mean, it's what where were you? Yeah, like so on page 180 182, you covered this. It's a like the last paragraph says to get at that font class above, you just say rendering double colon
yeah,
font.
yeah, yeah,
Yeah. But if you sort of include the rendering module, if you just at the top of of a class
yeah,
say include rendering, then underneath it, you don't need to use the whole syntax of rendering double colon font. You can just say font.
yeah, yeah. That makes sense. So going back to page 185, my question is about how do these require statements come in? Because we have two files. One is font.rb and another one is paper size, which is also a Ruby file. So I don't understand why he's requiring the font here and the paper size. What is he trying to achieve with this code?
Well, he put them both under the module rendering, and he's saying like you can build up modules a little bit at a time, so you don't need to put them all in one big file and work with them in a whole file, because that file could be 1,000 lines long, right? Like, and it could
Yeah,
have and it could have 10 classes in it, and that's going to be really hard to work with. You have 10 classes in a file that's 1,000 lines long, and that's all in a single module. Like that's not a great ergonomics to work with. So instead, you build it up a little bit at a time by creating a font.rb file. And in that file, you say, okay, this font.rb file is going to be inside a module called rendering. And then you create a papersize.rb file, and you say, okay, this papersize class is going to be inside also a rendering module, and it's the same rendering module, and and that module is getting built up a little bit at a time. And each new file that it finds, it's going to add any classes in there. It's going to add any methods. It's going to add any variables or
constant.
constants into that
Yeah.
module.
Ah, okay, that makes sense. This part had confused me a bit. So I don't know where I had stopped at. Was it 183?
Mm, Yeah, but that's well, you were at 185, I think,
Oh, okay.
because you had talked about adding. So you can add classes to a module. You can add constants to a module. 184 was adding methods to a module,
Methods. Yeah. So I think
and
that's where I was at.
we covered 185, which was the whole conversation about like incrementally building up the module. And now we're at 186.
Oh, okay. So everything in Ruby is an object, and modules are not the exception to this. So this semi chapter on page 186 explains that concept, and what the idea the author tries to explain here is the fact that you can have a rendering, a module, sorry, and in this case the module is called rendering, being the value of a variable, in this case the module, and you can use that variable name to be a placeholder for what used to be the name of the module. So here we have a variable named the module. This is a variable name, and then we assign it to the rendering module, which is the module we've been dealing with all along. And then we create a new font named Times New Roman. And instead of writing out the name of the module, which is rendering, and then adding the double colon and then calling new on font, this time around we use the variable name, which is the module, the underscore module, to be a placeholder, or something that we place in the position of what would have been the name of the module, in this case rendering. And this is what the author talks about. And then the following code that follows related to the printers, he shows you how this fact that you can assign a module to a variable, how it's going to help you do around with some classes that have a lot of duplication, in the sense that when you look at the code on on page 187, we create a module called tons of toner. And then in this module, we have a print queue class. And then we also have an administration class. And then we do the same for the inkjet printer. Remember, for each of these printers had two classes that were related to it. One is for the print queue and the other is for the administration. So we have two modules, one for the inkjet printer and the other for the laser printer. And then what we see here is that the assignment helps us check using an if statement by saying, if we are using a laser printer, print module is going to be tons of toner. And tons of toner here is the name of the module that we created that is related to the laser printer. So we assign this variable name, which is called print module, and we assign it to the module name, which is tons of toner. And then as part of the else section of the if statement, we assign another variable, still the name is print module, to oceans of ink, which is another module that we created that is related to the inkjet printer. So what we are seeing here is that we set, reading from the book, we can set a variable to the correct printer type module, and from then on forget about which kind of printer we are dealing with by using this if statement. So we can see that we can create a new object by saying admin. The new object is admin. Admin is equal to print module double colon administration new. And remember that since the administration class exists in both modules, depending on what this if statement is going to return, we'll either have tons of toner being the placing of print module, or oceans of ink, depending on the kind of printer we are dealing with. And that is what this semi-chapter deals with. The
Yeah.
fact that everything in Ruby is an object and modules are not the exception to that rule. And because modules are objects as well, you can assign those objects to be the value of variables. And then we proceed to the next section, which is
Hold on.
staying out of trouble.
Before we proceed to the next section, I want to say something about this. So
Okay.
this is very interesting to me because I hadn't thought of using modules in this way. So he's he's using the concept of interfaces. Other programming languages have like the like explicit language syntax for creating interfaces. Ruby is a lot less structured that way, where it relies a lot more on let's say duck typing. Um, so if you have various different birds, like you don't really need them to all inherit from like some bird class. As long as you have um, a duck or a mallard or an eagle, if they all have a method on them, if all those classes have a method on them called
Yeah.
fly, then you can just create a whole list of them and just do call that method on those individual like on all those classes, right? And that
Yeah.
helps you like change or be a lot more flexible about what classes you're using. But that's when you're calling a method that isn't something like new. Here, we're seeing something interesting because it's a little bit more different and it's a little more subtle because what we're saying is okay, I'm going to set up this interface where we have a print queue class in tons of toner and a print queue class in what is it?
Oceans of
Oceans of
ink.
ink. Yeah,
Yeah.
in Oceans of Ink. So we have those classes. Those classes, it's not that the method is the same, the class names are the same. And so because we have the same class name, we can say we can be dynamic on what classes we create. So this is a different way of building objects. So instead of being dynamic about the method that we call, we're being dynamic about the
The
object that we
module.
create. And and it's super interesting to me because it's not a technique I've really used, but it's something that I could see coming in handy, where you build this interface where you just say, okay, I'm going to create a whole bunch of classes that all have the same name, and because they all have the same name, I can dynamically or more flexibly create the right object at runtime based on certain conditions. So it was really interesting to me, and it's not something that I've thought of before.
Okay. So I think I was at page 189, right?
Yeah, you're on 189.
Yeah. Yeah. So staying out of trouble. The question is, when should you create a namespace module and when should you let your classes go naked? An easy rule of thumb is that if you find yourself creating a lot of names that all start with the same word, perhaps tons of toner print queue and tons of toner administration, then you may need a tons of toner module. I think this is kind of similar to what we've looked the variable example we've looked at. I don't know if you see it in that one also, because here the name we are dealing with, the name of the module is tons of toner, and given that tons of toner is a module, if we assign this module to 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 a variable, and then we call that variable. And I think we can do away with this kind of syntax. Yeah.
Sorry, what do you mean this kind of syntax?
No, like I was kind of relating this example here, whereby
Yeah.
he says an easy rule of thumb. This is page 189.
Hmm.
An easy rule of thumb is that if you find yourself creating a lot of names that all start with the same word, perhaps tons of toner print queue and tons of toner administration, then you just may need to create a tons of toner module.
Yeah.
So I'm taking it one step further, and I'm like, this tons of toner module, just like he has said before, that modules are objects as well. You can assign this tons of toner module to be a value for a given variable that you decide, and then you can use that variable name instead of calling tons of toner like the name of the module.
Yeah. Yeah. Yeah,
Yeah,
that's the example that we saw earlier. Yeah.
yeah. And then we'll look at something that's very interesting here, module level methods. I think it was last week we talked about singleton methods and class level methods. And what the key idea from that discussion was that previously we were looking at methods that are called on instances of a class. So last week we looked at methods that are called on the actual class itself, and that makes them class level methods. So on page 189, we see another kind of methods, which is module level methods, or methods that can be called on the actual module itself. And then we see that by prefixing the method name with self inside the module, the points to inches method becomes a module level method instead of a normal instance method. And by the fact that this self is going to return word processor, which is the current module we are dealing with, points to inches. The points to inches method is a module level method and not an instance method or a class level method, but rather a module level method. And contrary to what we see when creating a module level method, the next section of the code shows you the points to inches method defined without the self. And in this case, points to inches is not a module level method, but rather an instance method. And he talks about it here by saying the first version of word processor creates a module level method that any code can use. That means this method is available globally. The second version creates a method that might be great when mixed into a class, but is useless as a widely available utility method. And then the next part of staying out of trouble is that whole thing to do with nesting, and the fact that if you've done a lot of deep nesting within your module, you'll have to reference all these things that you nest in the module in the order they appear. Therefore, the kind of code that you write now, let's say on page 190, if you want to access the font class, which is within the glyph set module, with the glyph set module being inside rendering module, with the rendering module being inside output, and so on and so forth. This kind of thing that you type here, whereby you say subsystem double colon output, it kind of gets very long. So I think precaution is necessary so that you don't do a lot of deep nesting within your modules. And
Yeah.
the
Although
section of in the while.
it's really hard to avoid when you have
Mm,
a big code base because it's very hard for another developer to say, "Oh, I'm gonna change the way this is structured." Um, and do it another way because this is too long. Because people are just like, okay, I'm going to create a new class, and I guess it's going to go under glyph set, and it's font, okay, and it just keeps getting longer and longer and longer, and it's 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 by following the conventions that have already been set, you reach a point where the complexity starts to increase and increase. And it's very, very hard to simplify. But yeah, like I agree. In theory, it's very you should avoid it. In practice, it's it's hard to avoid.
Yeah, so I've seen the banner. We have like, I don't know, I think less than 10 minutes. So I'm going to try to breeze through chapter 16.
Oh yeah, okay.
Yeah. So chapter 16, it builds upon the idea of mixing in a module into a class. And here we see two keywords. One of them is include and the other is extend. So what we are going to look at first is that why do we need to mix a module into a class? We have two classes that are unrelated, but they need to share behavior. So instead of breaking the inheritance tree and making these two classes inherit from a superclass and having the behavior defined in the superclass, we can mix a module with that behavior into both of these classes. And here you see page 194, we have code that is checking for the number of cliches, and we want the document class as well as the electronic book class to have this behavior. So instead of breaking the inheritance trio hierarchy, what we are going to do is we are going to create a module. This is page 195. We create a module called writing quality, and we move this code, the code checking for the number of cliches in a text, and we put it inside this module. And then we mix this module into the document class and the electronic book class by using the include keyword. So after doing that, we can see that we can call the number of cliches method that is defined in the writing quality module on an instance of both the document class and the electronic book class. And one thing to note is that the number of cliches method that was initially defined in the writing quality module is an instance method. That is why you see that we can call it on any instance of these two classes. It's not a module level method, but rather an instance method. So that is something to take note of. And here I'm going to read something from the text. The Ruby jargon is that by including a module in a class, you have mixed it into the class. And we say that the module itself, writing quality, in this case, is a mixing module. And a very useful aspect of mixins is that they are not limited by the one superclass is all you get rule. So you can mix this module into as many classes as you want, as long as you want this behavior to be available for that class. And then moving on to 197, extending a module. So sometimes we want to mix a module into a class, but rather instead of having the methods defined in the module being called on instances of that class, we want these methods to be called on the actual class itself. So if for purposes of that, we'll use extend instead of include. And you can see here that we have a finders module, and we extend the document class by including the finders module. So we have class document, we extend finders, and then we close off the class. By using extend instead of include, we can call find by name or the find by name method on the actual class, which is document, instead of an instance of document. Therefore, this find by name method is a class level method that is available for the document class. And that is one of the distinctions between using include and using extend. Staying out of trouble is the next section, section. And here we talk about the inheritance tree. And the key idea is that when you include a module into a class, for example, referencing this image on page 199, we've included the writing quality module into the document class. The module that has been included becomes a pseudo class, a pseudo superclass to the document class, which means that it will exist in between the object class, and the document class. So therefore, when Ruby is trying to execute your code, the methods that the module methods you've made available for document, when Ruby looks inside the document class and it can't find them, it will look in the writing quality class. And if it finds them, the methods will be executed, or you'll have the associated output with the methods. And another thing to look at is if you mix in two modules in the same class, the last module that you mixed in will appear just directly above the class. And then above that last module you mixed in, you'll have the module you mixed in first, and then you'll have the object class. So that is really what this section talks about. And then of course you can see the ancestors of the document class. If you're trying to prove that writing quality is really a pseudo class and exists in the inheritance tree, you can call the ancestors method on document, and its output will be an array that shows you that we have document writing quality, which is a module, and then the object class, kernel class, and then basic object. And I think, yeah, that's it for the most part. I don't know, Nelson, if you have something to add on that.
Yeah, we're out of time. I will see you next week, and we'll cover the next two chapters, chapters 17 and 18.
Okay, you have a good one.
All right, take care.
Take care.